All right, in this video, we're going to be wrapping up our various different area calculations, and then we will be progressing on to volume. So we're going to go from two-dimensional to three-dimensional. However, before we do that, there's one more thing I want to consider, and that is, in this video, you're going to be writing integrals. You don't necessarily have to solve them. Hopefully, you're pretty comfortable with that by now. But in this video, we're going to write integrals both in terms of x and in terms of y. So basically, how could we find this area if we were given a function in terms of x, or if we were given a function in terms of y? Now you might wonder why we'd want to do that. And I'm going to just draw a quick example here to kind of illustrate this. So what if we had some function, maybe this is our first one, and here's our second one, like that. Now you could probably figure out which we would call the top and which would be the bottom, right? You would probably call this one the top, right? And this one the bottom because it's underneath, right? But there is a different way of looking at this, and we're not always given a function in terms of x either. So the other way of looking at this is instead of doing the top minus the bottom for the area, typically what we think, area from A to B of the top minus the bottom. Another way to look at this is in terms of y's, and instead of thinking of it as top minus bottom, is the integral we're going to say from C to D, and that's going to be the right minus the left. And I'm going to throw a little dy on there, and with this one I'm going to throw a dx on. So there's really two ways we could consider the area between two curves. One is looking at the top function minus the bottom function, integrating that from A to B. And the other way is to look at it from the right function minus the left function in terms of y, and integrating it from C to D. So that is what we're going to be asked to do. We're going to be asked to write two integrals like this, which work for finding the area of this function. All right, so we're given the two functions. You also need to figure out which function is which based on this graph, which hopefully you can do that. So in this particular function, we've got the natural log of x, and we've got some linear equation 1/3 x minus 1. I'm going to go ahead and erase this real quick. All right. So let's first look at it as the way that we're most comfortable with, and that is the top function minus the bottom function. So our top function here is this one, right? And that is the natural log of x. F of x equals the natural log of x. And just while we're talking about this, remember that f of x is the same thing as saying y. So this would be equivalent to saying y equals ln of x, right? And that's our top one. And then our bottom one is this linear equation here. That is my g of x, which is 1/3 x minus 1. Or we could say y equals 1/3 x minus 1. Right? Okay, so those are our two equations in terms of x. If we want to do the top function minus the bottom function, well, that would mean the area is going to be the integral from ln of x minus 1/3 x minus 1, with parentheses around that, dx. Okay, now the other thing that we need is the x values, right? Remember these limits we need to know, and these should be x values. Since we got x inside of our function, right, these are x values, these limits should also be x values. So as a general rule, if you have x's inside of your integral there, then you want x values for your limits. When we look at y values for our integral, then we're going to want y values for our limits. All right, now the easiest way to find this, I suppose you could graph these on your calculator, and you could find them that way, find the points of intersection. That would be one way to do it. I'm going to actually try another way. Actually, it's probably not doable on this one. Another option, which you can do in some cases, is to just set the two functions equal to each other. So since they're both y, you just would do 1/3 x minus 1 equals ln of x. That's going to probably not be the funnest thing to solve, though, for this case. So we got a natural log. We'd have to e it, and then it's not going to be so good. So let's go ahead and pull out our graphing calculator. Go ahead and just plug those two functions in. You can do this too while I'm doing it. ln of x, and then we've got 1/3 x minus 1. Graph it. I got some stat plots on here. I have to change this really quick. All right, so we'll go ahead and graph it. Do your intersect. Sorry, it's taking a while. I had to get rid of those stat plots. All right, so do second calc intersect. This does say calculator section, by the way, on the AP test, so you would definitely be able to use your calculators for this. So my first one, my bottom limit there is going to be 0.42368. That's probably plenty. And then my top one, same deal. Move my cursor over a little bit, closer to the other intersection. We get 9.8678. That should be good enough. All right, so those are going to be my limits. So I'm just going to go ahead and type those in. Again, I don't actually have to find them. Let me see if it tells you what's around here. Nearest thousandth. Okay. So we've got that. We got tens, hundreds, thousands. So we want our x1 is going to be 0.424. And my x2 is going to be 9.868. And then my integral then, I'm just going to go ahead and type in ln x minus 1/3. You can distribute that through if you want to, but I think it should work fine if you just basically put all your parentheses. 1/3, I'm going to close that, x minus 1, and that should be good. I already got our dx there. Okay, so we got our x part covered. Let's go ahead and do y's now. So in order to do this to y's, we have to write our functions in terms of y. So I'm going to take my two functions. I had, I'm going to write y equals ln x, and I'm going to basically solve for x, okay? Because I need to rewrite this, so it's kind of like finding the inverse, solve for x. So to do that in this one, I need to take the e, you need to e both sides. So we have e to the y equals x. So this is my function e to the y, because I got the x by itself. And that is actually going to be sort of the left function, right? That's that one. So this is going to be my left function on that back side. And then in my other function as well, I also need to do that. So I had 1/3 x minus 1 equals, we'll say y equals that. So then I just add the 1 over. So y plus 1 equals 1/3 x. And then I just need to multiply everything by 3. So x equals 3y minus 3. Just times by 3 to get rid of that 1/3. All right, so that's my other function. This is going to be my right function. Okay. So for my right function, when I type this one out, it's going to be the right minus the left. So it's going to be the integral of right function, so 3y minus 3 minus e to the y dy. And along with this, I also need the y's. These should be y's because I got y's inside of my integral. Now, if you were smart, which I wasn't, you want to go ahead and write down the y coordinates of the intersection as well, because when you find the intersect, it actually tells you the x and the y. I do still have the y for my second one, and that is at 2.2892. And then so that's my upper limit. My lower limit, just need to go ahead and do that real quick, is going to be, so you don't need to retype anything in your function, just type it in like that. The y coordinate there is negative 0.8587. So now I can go ahead and type this in. Again, rounding to the nearest thousandth, so negative 0.859. And my y2 then is 2.289. And then I'm going to type this in terms of y, so 3y minus 3 minus e to the y. And I already got my dy.